Hi, I'm Miss Isaac. Hi, I'm East.
And this is lesson 56, adding and subtracting rational expressions with unlike denominators.
Oh yeah, I'm easy.
Example 3, adding with unlike denominators. You'll remember that in order to add a fraction, you must have common denominators. And to start with, we do not. So we need to get common denominators. We're going to use the skill from last lesson, which is finding the least common multiple of the two pieces I underlined. And that will be our common denominator. So if you remember, we're going to completely factor each term. So we have 9x squared. It's going to be 3 times 3 times x squared. And I'm going to completely factor the second denominator. There's a GCF there, which is 3x. And then we'll have x plus 1. I'm going to look for any common factors. We have a 3. I'm going to pull 1, 3 down. And we have 1x. We're still left with an x here. So we have 1 common x. And then I'll pull everything else down. We have a second x. We have the 3. And we have the x plus 1. So to simplify, our common denominator is 9x squared times x plus 1. Okay. So that's the first part. Now, we originally had 7 over 9x squared. To get our goal of a common denominator of 9x squared times x plus 1, we're going to have to multiply the first rational by x plus 1 in the denominator to get the common denominator, so I'll have to multiply the numerator also by x plus 1. Plus, it's going to help me if I factor the denominator to be 3x times x plus 1. And we have a numerator of x. Again, my goal is 9x squared times x plus 1. So I need to multiply the denominator by 3x, which means I need to multiply the numerator by 3x. Okay, let's do this multiplying. Distribute the 7. Get 7x plus 7 over. Keep the denominator 9x squared times x plus 1 plus the second term becomes 3x squared over 9x squared times x plus 1. Now I have common denominators, and when I add fractions, I keep the denominator the same. I get 9x squared times x plus 1, and I add the numerators. I'm going to put 3x squared plus 7x plus 7. You'll notice I put the numerator in standard form with descending exponents. And I'll see, is there anything more I can factor? And there isn't. So this is my answer. Now, some of you might be asking, do I really need to find the least common denominator? Couldn't I just find a common denominator? And you could. And you're going to get the same answer. So I'm going to show you another way to do this problem. Okay, instead of finding the least common denominator, we're going to find the most common denominator. I'm going to rewrite the expressions. Now what happens is I'm going to multiply the first rational by 3x squared plus 3x times the denominator of the second rational. What I do on the bottom, I have to do on the top. 3x squared plus 3x. And now to the second term, I'm going to be multiplying 9x squared and 9x squared. Okay, let's do this multiplying. I get 21x squared plus 21x over 9x squared times 3x squared plus 3x plus 9x cubed over 9x squared times 3x squared plus 3x. Okay, and now I add. I get 9x cubed plus 21x squared plus 21x all over 9x squared times 3x squared plus 3x. Here I can simplify, so I'm not done. I can pull out a GCF of the numerator, which is 3x, and I have 3x squared plus 7x plus 7, and I can pull out a 3x in the denominator. So I have 3x times 3x and 3x squared plus 3x. Okay, and I have a common factor, the numerator and denominator, so I get rid of it. And now I have 3x squared plus 7x plus 7 over 3x, and I can pull out a GCF of 3x times x plus 1. I can just rewrite the denominator as 9x squared, like this. Rewrite it 9x squared times x plus 1. So you see I get the same answer if I use a common denominator and not the least common denominator. Okay, in example 4, we'll be subtracting with unlike denominators. After doing the previous example with a common denominator and the least common, I prefer the least common. I want to do all my work up front and not at the end. So I'll have to find the least common multiple of these two denominators. I have 2 times x minus 1 and x minus 3, x minus 1. So 2x minus 1, x minus 3 is my common denominator, my least common denominator. Okay. So I have 2x minus 2 and x plus 2, which I will be multiplying both of these by x minus 3, plus I have negative 2x minus 1, and then rewrite the denominator as x minus 3 times x minus 1. And so what I'm missing here is the 2. Okay. X plus 2 times x minus 3 all over 2 times x minus 1 times x minus 3. I'm going to keep everything factored. Maybe it'll help me at the end when I have to simplify it. And then I have negative 4x minus 2 all over 2 times x minus 1 times x minus 3. I have common denominators. Now I see that I'm going to be adding the numerators, so I'm going to take that back. I'm actually going to FOIL the first numerator so that I can then combine like terms. Often with these problems, you're going to play around with if you have factored form or unfactored form. The denominator stays factored, says the couch. Denominator stays factored. So I'm going to rewrite this as x squared minus x minus 6. Now I'll add the numerators. X squared. Oh my goodness. Almost a huge mistake. You are not adding these. We are subtracting. So this is really minus a negative 4x, which becomes plus 4x. So that's really 3x. Right? Negative x minus a negative 4x is positive 3x. Negative 6 minus a negative 2 is really negative 6 plus 2 is negative 4. Denominator stays in factored form. And now I'm going to factor the numerator to see if there's any common factors. We have x plus 4, x minus 1. The numerator, denominator. We do have a common factor. We can get rid of the x minus 1. And we end up with x plus 4 over 2 times x minus 3. We have to list the restricted domain because the x minus 1 factor in the denominator that we got rid of is undefined when x equals 1, so x cannot equal 1. And there is our answer.